Okay, folks, we are on 3-2. We finished up with like example 2, and then we did up until this point, okay? We have to talk about converse, inverse, and contrapositive yet. But I'm going to go over, and I'm going to put it all in one spot, and I don't like to use, they use too many words. They use too many words. So go to 163, and you see this little margin over here? We're going to put this in this margin, because you're going to refer back to it. And I'm going to do it in less words than they do, because they get too wordy, okay? So here we go. Yesterday, we were talking about dogs have 4 legs. Write that down. Okay, dogs have 4 legs. That's a statement. Dogs have 4 legs. I understand some dogs don't. Some dogs have only 3 legs. Some dogs only have 2. But for now, we're just going to say dogs have 4 legs. Go. Okay? Now, I want to write that into a statement that's called a conditional statement. Conditional, okay? And a conditional, like if your mom gives you a condition, like you can only do this under certain conditions. A conditional statement is if something happens, then something happens, right? Like if you clean your room, then you can go out on the weekend, right? A condition. You can only do certain things under a certain condition. So conditional is if then. If then, okay? When they say write a conditional statement, that's what they mean. If then form. Okay, so how do I put dogs have 4 legs into if then form?
If it's a dog, it has 4 legs.
If it is a dog, comma, then it has 4 legs. Okay, and then yesterday we talked about how a conditional has 2 parts. The if part is called the, do you remember?
Who knows? I don't know.
The if part is called the what?
Margin.
The hypothesis.
Hippo.
The if part is called the hypothesis. The then part is called the conclusion. Okay? If and then. Thank you. Okay? If something happens, then something happens. Hypothesis, conclusion. What?
The blower and hit power, right?
Yeah, and the switch.
Oh, I did.
Okay. Yeah, it's fine. I think the power automatically turns them off anyway. It's fine. Okay. Hypothesis, conclusion. Got it? Okay. All right, I'm gonna write a conditional. I'm gonna write a conditional in symbol format. What? You will use logic and reasoning in the real world. Yes. Okay. All right. This conditional I'm gonna write in symbol format. Here we go. Write this next to conditional. P, then Q. Do P arrow Q. That means P then Q. The P part is the hypothesis part. The Q part is the conclusion part. So P then Q. That's what symbol format of a conditional statement looks like. Got it?
So the arrows should go in if to them.
Yes. Yes. This is the if part. This is the then part. Got it? Good? All right. Next thing is the converse. Okay? Converse. Not the shoe. Converse. Here's what converse says. Ready? Converse takes it and switches it around. So it's Q, then P. So if I switch those 2 statements around, what will that say?
It has 4.
Nope. Nope. It changes the if and then part too. So if what? If it has 4 legs,
Then it a dog.
whoop, legs, then it is a dog.
That's what I said.
Okay, sure.
Well, it could be a cat.
Okay, hold on. Now we got to talk about the truth value. Let's say that the conditional value is true. I understand that some dogs don't have 4 legs, whatever, but that's under rare circumstances, okay? So if it is a dog, then it has 4 legs. That is true, correct? If it has 4 legs, then it is a dog.
Not true.
Not true. Right? Now, it is not always the case that if this one is true, then this one is false, right? They could both be true, right?
What would be the circumstance?
I don't know. We'll see that here in just a little bit. If they're vertical angles, then they are congruent. Well, no, that's not true, because if they're congruent, they're not vertical angles. We'll do an example later on. Okay, I gotta think harder. Okay, not necessarily true that if one's true, the other one's false. Okay, that is the converse. Got it? Then we have something called the inverse. The inverse. Okay? All right, here's what the inverse does. It starts with the conditional, except it puts not in front. So not P, then not Q. Do you know that little squiggle? right? That squiggle means not P. So it's the same order as the conditional, but not in front of it, okay? So take this and make it not. Okay, if what?
It is not.
If not a dog, then not 4 legs.
And it doesn't have 4 legs.
Right. I'm just paraphrasing. If it's not a dog, then it does not have 4 legs. Okay, let's see if that's true or false. If we're not talking about a dog, does that mean it does not have 4 legs? No, because we could still be talking about something with 4 legs, right? So that is false. If it's not a dog, that doesn't necessarily mean my animal's not a 4-legged animal, right? So that is false, okay? Now, the last one is something called a contrapositive. Contrapositive. I don't know where these names come from, okay? All right, if you had to guess his pattern, what do you think his pattern would be? What?
If it is
Hold on. It's the opposite of the converse. So converse, hold on. Symbols. What would the symbols be? Squiggle Q, then squiggle P. Okay, do you see how this works? We have P, then Q. We have Q, then P. We have not P, then not Q. We have not Q, then not P. Got it?
We have to memorize these.
No, I'm going to have you write them down on a note card. Okay? All right, so contrapositive. We're looking at the converse. When we contrapositive, we're going to not this thing, right? If what?
If it doesn't have 4 legs, it's not a dog.
If not 4 legs, then not dog. Okay, so the animal that I'm talking about does not have 4 legs. Does that mean that animal can't be a dog?
False.
It's true.
Well,
My animal doesn't have 4 legs. My animal is a 2-legged animal, right?
Or 3.
Now, we're saying we're excluding rare circumstances, right? Okay? If the animal that I have does not have 4 legs, then it is not a dog. True.
what?
Got it?
What type of yours? Only 2 like birds? Or
just
what?
kidding.
Well, like a bird, or maybe it doesn't. Maybe I have a snake and it doesn't have any legs at all. I don't know, right? Or a child, right?
Or a hippopotamus.
Okay, could be a child. I don't know. Okay, does this make sense? We're just looking at all of the options, right? And reasoning through them. All right, here we go. Example 3. Shh. Example 3. Shh. Listen. All right, example 3. Shh. Shh. Just wait. What? Does a monkey have 4 legs or 2 and 2? I have no idea.
And it has.
I think a monkey has 2 legs and 2 hands. Yeah. What? Do you think it has 4 arms? Maybe. Right. Sure. All right. Hey, okay, example 3. Shh. Listen. Shh. Listen. Example 3. Okay. Identify hypothesis and conclusion. Listen. If a polygon has 6 sides, then it is a hexagon. They've done this one for you. The if part is always the hypothesis. So a polygon has 6 sides. Then it is a hexagon. The polygon is a hexagon. That's the conclusion. Got it? Let's do the second one. They don't have that one done for us. It says another performance will be scheduled if the first one is sold out. What's the hypothesis? No, that's the conclusion. This one is flipped around. The hypothesis is always the if. So if the first one is sold out. Yeah. If the first one is sold out. The conclusion is? Another, I can't spell, performance will be scheduled. Simon, are you writing this down?
Yes.
No, you're not.
I'm not.
Don't lie to me. Okay. There you go. Hypothesis, conclusion. Do we have that figured out? On the homework assignment, listen. On the homework assignment, you can underline and just write an H and a C. I don't care. Good? All right. Go to 4. Go to 4. Write the conditional in if-then form. 4 quarters can be exchanged for a $1 bill. They wrote that in if-then form. They said if you have 4 quarters, then you can exchange them for a $1 bill. Okay? All right, here we go. The sum of the measures of 2 supplementary angles is 180. How do I write that in if-then form? If what?
If the angle is, if the
sum
If there's
of
two
two measures
supplementary
is 180.
angles,
They're
then-
supplementary angles.
Then the sum of the two supplementary angles is 180.
Okay, what did you say?
Or if
If what?
If
Lauren's
the sum of
works.
Two
Yeah.
measures is 180.
That's what Lauren said. Yeah?
I agree.
if the sum of the measures is 180 degrees, then it's two supplementary.
If sum is 180, you guys are all saying the same thing Lauren said. Yep. If sum is 180, then supplementary, right? Could you have said that backwards and said if supplementary, then the sum is 180?
Why not?
Why not? That works too, right? So that one you could do two different ways. Okay?
I heard.
If the sum is 180, then supplementary. So, hypothesis, if 180, conclusion, then supplementary. I'm really paraphrasing, right? If 180, then supplementary. There we go.
Yay.
Got it? All right, example 5. Okay, we're talking about a tang fish. I have no idea what a tang is. Have you heard of a tang fish before? Tang? Hey, guys, the sooner you listen, the sooner we will get done. The sooner you listen, the sooner we will get done. I will wait for you all to be quiet. Okay, we're talking about a tang fish. I don't want to read the paragraph. I'm just going to start with the conditional. Here we go. If a fish is a tang, then it lives in salt water. Okay? That is PQ, right? P, then Q. Got it? Converse. What order does converse go? Q, then P. So we have to switch that statement around, and it says if it lives in salt water, then
It's a tank.
it is a tang fish.
Which is incorrect.
Okay? Is that true or false?
False.
False. Okay? Is the original one true or false? If the fish is a tang, then it lives in salt water? True. Okay? They gave a counterexample. They said a surgeonfish lives in salt water, but it's not a tang, right? So that's a counterexample to that. Therefore, the converse is false. Okay? Now the inverse. The inverse goes PQ, but it's not, right? Not and not. So if it's not a tang, then it does not live in salt water, right? So if the fish I'm talking about is not a tang fish, does that mean it can't live in salt water? No, because a surgeonfish is a counterexample, okay? But it does live in salt water, so that is false. And contrapositive goes not Q, not P. Shh. Shh. Brady, be quiet. Not Q. So if I go back to Q, P, if I go back to the converse, if a fish lives in salt water, if a fish does not live in salt water, then it is not a tang. If the fish I'm talking about does not live in salt water, that means it lives in fresh water. Does that mean it can't be a tang?
It can't be.
True.
Because
Based on the information above, the statement is true, right? If it doesn't live in salt water, that means it can't be a tang fish, because tang fish only live in salt water. Got it? You have to really think about it sometimes. Like, how does that work? Got it? Beautiful? Okay. All right, last thing. Last thing. This is what Zach was just talking about. Okay? All right, we were just saying above that you have a conditional statement, which is the if then, and then you have the converse, right? Write this off to the side. Conditional is PQ, converse is QP. All right, PQ, QP. This last concept is something called a biconditional. Bi means two. So under two conditions, right? Here's how a biconditional works. If the conditional is true and the converse is also true, then the biconditional, the two conditions, are true, right? If it's true and true, the whole thing is true under a biconditional. Here's how this works. Okay, let's go to part B, and then we'll bump back up to part A, all right? Part B says, if two lines are parallel, then they have the same slope and different y-intercepts. Okay, let's talk about two parallel lines. You remember two lines that are parallel, y equals mx plus b? Y equals mx plus b, right? They're saying they have the same slope. So like, let's say they both have a slope of 2 and their y-intercepts are different. So this one has a y-intercept of 4 and this one has a y-intercept of -3. Are these two lines parallel?
Yeah.
Yes. So that is true. If two lines are parallel, then they have the same slope and different y-intercepts. Okay? So the conditional reads, if parallel, then same M, different B, essentially is what that's saying, right? If they're parallel, then they have the same M and different B. True or false? True. Okay? The converse, if I flip that around,
If
reads,
not parallel.
no, converse is QP.
If it
Oh,
has
yeah,
the
yeah,
same M.
If same M, different B, then parallel.
Yeah.
Is that true? That is also true, right? Okay? So, the way that we write this as a biconditional says, the two lines are parallel if and only if same M, different B. Does that make sense? Rather than saying, if this happens, then this happens, we say, they are parallel if and only if. This is the part that you insert in the middle of the two statements, right? Two lines are parallel if and only if they have the same M and different B. If and only if means PQ is true and QP is true. Make sense? Okay, so the conditional and the converse are true, so the biconditional can be written. Okay, and it's written like that. Two lines are parallel if and only if. That's the part that you insert in. Okay, let's go back up to part A. Rasha listens to music when she's in study hall. So I'm going to say yes, music. Okay, I'm going to say Rasha, okay, hold on, back up. Rasha listens to music when she is in study hall. So if what? If study hall, then music. Right? I'm really paraphrasing. If she's in study hall, then she's listening to music. Yes? True or false? True. Okay? Now, if I flip that around, it would say if music, if she's listening to music, then she must be in study hall.
No.
Why is that not true?
Because she could listen to it next.
She might be listening to music at home, or she might be listening to music in math class. Hopefully not, right? But that could be a thing, right? So that is false. So the biconditional, because the converse is false, a biconditional statement cannot be written. Okay? If you were to write a biconditional statement, it would say, Rasha listens to music if and only if study hall, right? She listens to music if and only if she's in study hall, which is false, right? But that's what your biconditional would look like. She listens to music if and only if she is in study. If and only if. Is that an if? If and only if study hall. Okay? Does that make sense? If forward is true, backwards is true, you put if and only if in there, right? There's a lot of stuff packaged in this section. Woo! It's all like logic and reasoning. This is not my favorite thing to teach.
You're right.
I know it's not your favorite thing to learn, but it's like looking at like the specifics of things. It's like a rectangle or a square is a rectangle, but a rectangle is not a square, right? So if it's a square, then it's a rectangle. If it's a rectangle, is it a square? No. So the biconditional could not be written. It is a square if and only if it is a rectangle. That's not true, right?
It's like saying like a rhombus or something.
What?
Like a rhombus is a square, but a square is not a rhombus.
Correct. Also the same thing. Yes. Did you know that a square is the perfect combination of a rhombus and a rectangle?
No.
Yes, we will learn that.
What does that even mean?
A rhombus is a tilted square. So according to a rhombus, it has all four sides that are equal and it's a parallelogram. But it could be tilted, so it's a rhombus. A rectangle only has to have two sets of parallel sides and two sets of congruent sides and 90-degree angles, right? So it doesn't necessarily have to have all four sides equal, but a rhombus does. So when you combine a rhombus and a rectangle, it makes a square. it's like this is the Venn diagram for rhombus, rectangle, square. Here is rhombus land.
Maybe.
Here is rectangle land, and squares live here. Yeah.
So what is that?
And here is parallelogram land. There's rectangles are parallelograms, rhombuses are parallelograms, trapezoids live over here. Yeah. Kites live over here.
Wait, wouldn't a kite not a kite?
Yeah. Kite is a little different.'s not quite a
Can be
parallelogram.
a rhombus.
What?
A kite can be a rhombus.
I like my cheese drippy, bro.
It wouldn't be good.
I could technically be a square.
Yeah.
Long ass I
Yeah.
Then would it
A
live
kite
in-
can be a rhombus, but it doesn't have to be. What?
Wouldn't it be in that?
What?
Wouldn't it be in rhombus?
No,
rhombus
kite
land?
Can be a rhombus, but a rhombus.
So wait, would kite walks around?
So kite would look like this. Yeah.
Kite would overlap square too.
But isn't a square technically a kite too?
It would
Yeah.
overlap all of them. A kite can.
A kite would overlap like here
No, a kite would overlap everything.
because a kite can't be a rectangle.
Well,
No, a kite could be a rectangle. Gosh dang it. I don't know. I have to think about the specifics of what makes it what.
a kite.
Whatever. Don't listen to what that is. All right. You guys have lots of work to do.
No, we don't.
19, 24, 26, you're done?
Yeah.
Really? Writing out all the statements and everything?
Wanna see?
You're sure?
Yeah.
You're sure?
Well, Jacob, you can help me.
Okay.
I was taking an ACT prep.
All right. There you go. Goodbye.
Jacob,